Hello there, I'm Thomas, Hatsios, German-American pilot flying the Boeing 787 and had returned flight from Zurich International Airport. We are flying Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 14 for an ILS localizer landing around now in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787 and 100Z aircraft and Microsoft Flight Simulator X. I'm going to start showing you the cockpit instruments and displays and the functions of the Boeing 787 900Z aircraft. I'm going to start with the primary flight display. The displays the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric pressure of the atmosphere, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the vertical rate of climb on the aircraft in 10,000 feet per minute, and the signals of the trigonometric angles increase, it can climb and descend. We have also we have the altitude indicator with the artificial horizon, the pitch ladder decrease, the bank angle decrease, the ILS localizer. We have the horizontal localizer and the vertical glide slope of the ILS localizer of the instrument landing system of the airport. Runways we use for takeoff and for landing. So we have the Zurich International Airport, runway 14, Lszh in Switzerland. And we're going to use the ILS localizer for runway 14 in Lszh airport. So we're going to have tuned this frequency from the onboard ILS receiver antennas we have in the aircraft. Is going to help us align with the runway magnetic north pole heading for takeoffs and for landings, for aligning the aircraft in takeoff and for landing. So you're going to see the ILS localizer crossbars displayed in the primary flight display. We have also the flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for aeronautic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies and the flight mode annunciator with the autopilot and the auto throttle, later on vertical navigation mode. We have also the HSI, the horizontal situation indicator. Displays the magnetic heading and track, the magnetic north pole, the true north pole magnetic variation depending on where we are in the world. You can see also that in the navigation display we have the integrated flight plan display in the HSI. Also in the navigation display you can see the horizontal and vertical profile of the flight plan. We're going to create a flight plan or a flight path or a route for this aircraft for this flight using the flight management computer. So I will show you in a couple of minutes how we're gonna do that. So I'm gonna use the navigation display. We use it we have the display of the horizontal and vertical navigation profile of the aircraft, and we have also the terrain from the weather radar. You can see the weather reflections, the terrain reflections displayed with yellow, green, and red colors. So we have the sea with blue. We have also the terrain map with the airports. You can see the airport's location. So we are in the Zurich International Airport, runway 14. We're going to use for takeoff and for landing. You can see the runway orientation where we are located right now. Its length, its slope, everything is stored in the flight management computer we're going to use for takeoff and for landing. So I'm going to show you how we're going to use all this information. I'm gonna show you all the systems of the aircraft, then we're gonna make an engine start demonstration, and so you're gonna see an engine start demonstration. I'll show you before the engine start demonstration all the cockpit and aircraft systems of the Boeing 787 900 aircraft. So you're gonna see after that a complete flight from takeoff, climb, cruise, descent, approach, and landing in the part of the video. So right now I'm explaining about the navigation display. We have also the navigation aids, the ADFs, the NDBs, the workstations, the waypoints with our horizontal and vertical navigation fixes. You can see also other aircraft that fly around us using the transponder, the USB and ADC transmitter receiver, which transmits our frequency to other aircraft and the air traffic control, and also receives from other aircraft. And displays the diamond shape of the other aircraft. You can see this computer calculates the other aircraft distance from our aircraft, the altitude difference with our aircraft, the direction with respect to our aircraft, and also the velocity closing in. So it will calculate It will calculate if we have an incoming collision between our aircraft and other aircraft in the air or in the ground. It's gonna give us a warning using the TICAS system, the traffic collision advisory system. You can see also displaying in the primary flight display and the navigation display the warnings of the TICAS system. So we have, as I told you, you can see we're gonna use the waypoints for takeoff and for landing. So I'm gonna use the flight management computer. You can see here we have the primary flight display, navigation display, autopilot flight director system panel over here, the engines display. So we're gonna use the flight management computer here to create a flight plan. It's gonna be displayed here and here. You can see also the thrust levers. I'm gonna show you how to use all the thrust levers for the engines, the flaps and slats, the speed brakes, the flight controls over here. You're gonna see how I'm using the side stick to control the yoke of the Boeing 787. So we have control over the flight controls. So you see here for climb and descent, make turns left and right. So I'm gonna use the flight management computer. I'm gonna input all the data of the aircraft for this flight. That includes the takeoff gross weight, the empty weight, plus the passenger, plus the cargo, plus the fuel on board. That includes the fuel, the taxi fuel, the reserve fuel, and the trip fuel. So we're gonna have the calculations about the center of gravity of the aircraft. The flight management computer is gonna calculate how much fuel we have in the left and the right wing tank. We have 30% also in the center tank, and the loads from the compartments and the passengers is gonna give us the linear dynamic core position of the center of gravity. It's going to be 23% of the Mach of the linear dynamic core position of the forward wings is the position of the maximum aerodynamic lift occurs in the forward wings. So the position where the stall will begin for a given angle of attack in flight. The airfoil will become detached from the top surface of the wings, and pay attention over here. In the primary flight display, you can see the airspeed here indicated. You can also see, so we have the airspeed indicated. In the primary flight display, you can see the stall speed when we fly is gonna give like a yellow and red warning below us. So we need the airspeed always above the stall speed. The airspeed selected. The barometric altitude above the sea level. The barometric pressure of the outside atmosphere over here. The radio minimum, so the radio altitude above the ground level. The pitch ladder and decrease. So we're gonna have also maybe the flight director on over here. Like this, gonna give us more nice display. Flight director on. So we have the barometric pressure set here for the barometric altitude. So I'm gonna show you all the functions of the Boeing 787. You can see how we have set the airspeed indicated here. The airspeed selected and the altitude selected is the same values, and the heading like the autopilot flight director system panel, airspeed guidance here, heading guidance, altitude guidance, vertical rate of climb descent, auto throttle left and right, autopilot engage, disengage flight director. So I'm gonna show you the modes later of the autopilot flight director system panel here. So we're gonna see all these things. You're gonna see also so I'm gonna show you the flight management computer. As I told you, we input all the data of the aircraft for this flight. The center of gravity is calculated using the takeoff gross weight. You're gonna calculate the left and the right wing tank fuel on board, 30% right now, 10% in the center tank. So we're gonna have the linear dynamic core position, 33% of the Mach, and the center of gravity is gonna give us for the flaps. We're gonna use 15 degrees of flaps to take off. We're gonna have the horizontal tail, the horizontal stabilizer or horizontal tail of the aircraft, trim to about 4.25 degrees for pitching up the nose of the aircraft in flight, 4.25 degrees. Nose up is trim attitude. So you can, I'm gonna show you how to trim the horizontal tail of the aircraft during the whole flight, from takeoff, climb, cruises, and approach and landing. You can trim it either manually over here using this trim switch over here, or automatically using the autopilot flight director system panel and flight management computer and the auto throttle. So I'm gonna show you also the overhead panel later. doing the engine start demonstration. So I'm gonna show you all these controls. I will show you the flight management computer. Like telling you we're gonna use these things. We're gonna use the runway we're gonna use for takeoff the Zurich International Airport, Lszh runway 14. In Switzerland, we're gonna use the runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air, and the temperature of the air, and the runway conditions, if it is ice, dry, or wet. They're gonna give us the takeoff speeds from the flight management computer using the flaps for takeoff, and all the information, mean aerodynamic port and horizontal trim, stabilizer, and center gravity. It's gonna give us the takeoff speeds V1, V rotate, and the V2. Then we're gonna have the V2 plus 15 knots for takeoff. Then we're gonna have I'm gonna insert in the flight management computer to create the flight plan or flight path route using the magenta line you're gonna see with the legs. We're gonna be flying through. We have the seats. The seats are the standard instrument departure waypoints and fixes, that are horizontal and vertical navigation fixes for the initial climb of the aircraft and departure from the airport, and altitude and airspeed constraints. We're gonna have the climb to the cruise level at 25, 26, 27, 28, 29,000, 30,000 feet. We're gonna transverse through some waypoints like the Zui, the Negria, Amity, maybe then we're gonna have Zui again, then we're gonna have TRA and Z8701 Osman. So you're gonna see the waypoints we're gonna be transversed through in flight. We have to cross through for given altitude and airspeed. So we're gonna have the waypoints selected. It's gonna give us the material line of the flight plan. We're gonna have, as I told you, the top of climb, cruise. Then we're gonna have the top of descent. We're gonna start the descent back to the elevation of the airport, like 7,000 or 6,000 feet above its sea level. The elevation of the airport is 1,430 feet. So we're gonna have the stars, so the terminal arrival waypoints and fixes for the terminal arrival and approach and landing. You're gonna see the stars displayed and the navigation display also. So we're gonna have the stars align us with the runway for approach and landing in the long final and short final. Horizontal vertical guidance again. The angle of approach. So we're gonna have also the ILS localizer. As I told you, the horizontal localizer, the vertical glide slope of the instrument landing system of the airport. We're gonna use runway 14 Zurich International Airport in Zurich, Switzerland. So we're gonna have ILS localizer tuned automatically using the flight management computer or manually using the radio management panel. So it's going to be displayed in the primary flight display, the horizontal localizer, the vertical glide slope, and the cross bars we're going to use for alignment of the runway magnetic north pole heading. We're going to have 136 degrees of magnetic north pole heading of the runway 14 in the Lszh airport. So we're going to have also flaps like 35, 30 degrees, the landing gear down, and airspeed at 160, 170 knots. And also a pitch attitude of 9 degrees for approach and landing or less. Also we're gonna have 9 degrees and for takeoff, I forgot to mention, or less, to avoid that tail strike. So you're gonna see all these things. So I'm gonna show you the flight management computer, the outside view of the aircraft. I'm gonna show you over here. I'm gonna talk to you about Newton's physics, aeronautical and aerospace engineering. We derive some principle about the aircraft we need for flying. So you can see here the wings hold the aircraft weight as we fly using the airflow from the air mass. We have the thrust from the engines. So the airflow, we have the mean aerodynamic core position, about 23% of the max is pretty much here, with the maximum aerodynamic lift occurs in the forward wings, where the stall also will begin the top surface of the wing, so we need to avoid the stall. We have the axis here, the lateral axis from wingtip to wingtip, the longitudinal from nose to tail. That affects also the horizontal trim stabilizer over here, as I told you, the horizontal tail, so we can trim the horizontal tail, as you can see, for climb and descent like this. Also we're gonna have the vertical tail rudder. We can change direction, deflect the rudder, or just trim it. so it's easier to trim the horizontal tail in flight for climate descent. So you can see how we climate descent. I'm gonna show you the flight control. So we have the center of gravity, the vertical axis pretty much here where the main aerodynamic cord is. Then we have also here you can see the bottom surface of the wings is more flat and has the curvature from the flaps extended, and also as we're gonna be flying we're gonna be having an angle like this, so it's gonna give us using the Bernoulli theory of fluids, as we're gonna take off and after the airflow will be moving slower below the wings, so we're gonna have higher pressure which pressurizes the wings and the weight of the aircraft up into the air. So also using the Bernoulli theory of fluids, you can see the top surface of the wings is more curved, so the airflow is moving much faster above the wings, which creates lower pressure, which sucks the aircraft weight and wings up into the air. So this is the main principles: the thrust, the vectors also from the engines, and the deflections from the flight controls to change direction or balance the aircraft in flight. So you're gonna see how we're gonna do that. I'm gonna show you the flight management computer now, how to create the flight plan. Then I'm gonna show you the flight controls of the Boeing 787. So we're gonna create now the flight plan over here. Control Quantrat. So you can see here we have the flight management computer. We have also the mouse pad here. I will show you later. So you can see here we have the index over here. So we have the identity of the aircraft. This is the model Boeing 787-900, the engines, the air rack cycle, the position. We need the airport Lszh in Switzerland, and it's gonna give us the GPS coordinates. We need this one. So we have other things in the index: performance, takeoff, approach, performance, navigation, flight plan, load ATC, load plan, load AT traffic control route, save plan, save flight plan, announce its status. So you can use either one, whatever you like. So we go in the performance and the route. So we have the route. We use the departure Lszh airport origin over here. Copy paste runway. To clear that. So we need the 4-letter. Copy paste and again and one more time. So we have runway 14 over here. As you can see, departure of the origin destination airport. So this is the route 1. We can create more routes. You can see some messages here: destination airport. So you can see we have two displays. So we use the departures here and arrivals. Departure arrivals index. So we use ILS 14. We can select either one: Zui, approach. The seats are the standard instrument departure waypoints and fixes. Zui to Alpha. So we have departure arrival. As I told you can select either runway 14, 10, 16, 28 and other departure arrival seats. Also the arrival, you can use either runway. So we use ILS 14, Trans Amiki over here, and the stars are the starter terminal arrival waypoints and fixes. We're gonna use Negria like this. So we have departure arrivals completed. We have the route here not active yet. You don't see the Mazzetta color display in the status. You also have a discontinuity here in the flight plan. You have to close the waypoints one another, no discontinuity. So we go now here in the performance initialize. So we use, you can see 0 fuel weight plus fuel on board, gross weight for takeoff. So we have 322.7 thousand plus fuel, 35,000.6, gross weight 358.3, reserve fuel 5%, and cruising altitude 25,300. We use cost index 100%. Fuel freezing temperature, we're gonna having the fuel freezing in flight. You can see fuel freezing temperature, cruising center of gravity -37 degrees. So we need to recirculate the fuel automatically in flight, so we execute it because we're gonna fly with much lower temperatures. So we have the legs now activated. You can see the purple in the first waypoint color, so this give us the departure, first waypoint, second. There's at 135 degrees, 2 nautical miles, 250, 1900. Zui 302 knots, 6000 feet above the sea level. Negria 302 knots. This heading, we're gonna make some turns in flight. Flight level 22,100. Mativ 320, 11,800. Amity, we're gonna start the descent here for approach and landing. So Amity 190 knots, 10,400. Zui 180 knots, 7,000. Z8 Zurich 701, 186,000 alpha. TRA 180 knots, 5,000 alpha. CI14 180 knots, 4,000 alpha. 6 nautical miles. Osnem 5 nautical miles, 174,000 feet. And the runway 14, last leg of the waypoints, 8 nautical miles after Osnem, and 8 and 5, 40 nautical miles from C114. It's gonna be 140 knots, 1,400 feet. So we have also the takeoff go around here, some other waypoints you can use for a go around. So we have completed, we're gonna use flaps 15 degrees over here for takeoff. You can see again 15 degrees flaps over here. It's gonna give us the thrust, center of gravity here, automatically calculated. So you're gonna see here, center of gravity 28%, 4.25 degrees. V1, we rotate V2 for this runway. Takeoff data and gross weight. So everything agrees. Takeoff reference. The flight one is ready. You can see also we have other pages besides route departure hours. We have the alternate over here flight plan, the VNAV, vertical navigation, forecast also for the vertical navigation, progress over here, progress pace, FMC communications, hold over here. We can hold in flight, fix. So use either hold or fix over here. Hold in flight, fix to give you some indication in flight, and navigation radio. So this is all right now for the flight plan. We're going over here. So you will see the flight plan here created. It's gonna be displaying different things for the head-up display. Also for you're gonna see the flight plan display here. In the DHSI, the primary flight display here, the navigation display, and the DHSI, the primary flight display. We're gonna have different indications over here. So we have the flight plan displayed like this. Also on this page, you can change over here the range and the plan display. You can use the touch screen over here, as you can see. So I'm gonna show you now the flight controls, and then we're gonna look more detail over here of the Boeing 787. So I'm gonna start now with the flight controls of the Boeing 787-900Z aircraft. I'm gonna show you how to use all the side stick to control the Boeing 787-900Z aircraft, how to climb, how to descend using the control column of the yoke, how to make turns using the ailerons and the spoilers, bank rows left and bank rows right. So you can use the control column to move the elevator up and down. You select the horizontal tail elevator for climb and descent. to deflect the ailerons and the spoilers. In the left and right we use the control wheel, and we use the rudder pedals to deflect the rudder, the vertical tail rudder, for making yawing turns in the ground or in the air. So we have also in the rudder pedals interconnected the tiller until some airspeed in takeoff, like 76 knots, is going to be decreasing from nozzle deflection of 76 degrees left and right to like 7 degrees at about 40 knots, then to 0 degrees at to 70 knots in takeoff. We're going to have also the rudder is going to be aerodynamically effective at about 45 knots in takeoff. So you're going to see all these things. You're going to see also the horizontal trim stabilizer, how I'm going to trim the horizontal tail of the aircraft in climb and descent. I'm going to show you also the flaps and the slats, the speed brakes, the horizontal trim stabilizer, the thrust levers. We have many systems connected with the system of the side stick here. So I'm going to start now. I'm going to show you. So we have over here so we can climb and we can descend like this, make turns to the right and make turns to the left, use the rudder pedals. So we can see the side stick deflection is proportional to the yoke deflection. So we move the control column over here, moving the side stick, and it makes the elevator over here over the horizontal tail move up and move down, as you can see. So you can climb and you can descend like this. You use the force from the tail of the aircraft to climb and descend. You use the force over here from the rudder, from the vertical tail, to make left and right yawing turns. You use also ailerons and spoilers like this, left and right turn. So you can see left and right like this. Ailerons and spoilers, other one. Elevators. So I'm gonna show you now inside. So I hope you see how you move the elevator up and down. I'm using rudder pedals and also ailerons and spoilers like this. Make left and right turn, ailerons and spoilers. So you see ailerons left and right. So we have full deflection like this, ailerons and spoilers in the air to make left and right turns. So this is you can see we have also the tiller interconnected for the nozzle steering and the rudder pedals. We have the toe brakes and the rudder pedals. So this is all the flight control system. We have the flaps and the slats. I will show you the speed brakes later. Horizontal trim stabilizer also here and here and here, and horizontal auto trim cutout seat. So you can see the captain and the first officer are interconnected to move together in flight. Unless you have a failure, they're not like in the Airbus. You have the side stick priority. You can take other side using the side stick deflection. So also you can see, I'm gonna show you one more view now of the flight controls of the Boeing 787, and I'm gonna show you the system inside. So I'm gonna show you now a very nice view of the Boeing 787 flight controls, also the outside view for a couple of minutes. So we're gonna have here another view. Also the thrust levers, I forgot to mention. I'll show you how to move the thrust levers. So you can see here, this is the thrust. You can see some. Here we can see here. So you can see here we can climb and we can descend, make turns to the left and make turns over here to the right. So hope you like it. You can see the side stick I'm using to control the yoke of the Boeing 787. The side stick deflection proportion of the yoke, also the rudder pedals. You can see the deflection of the rudder pedals. So we have full control like this. Also the thrust levers over here, you can see forward and aft, and also the outside view again. You can see climb, descend, make turns left and right. So we climb and descend, turns in flight like this, left and right. So I'm gonna show you now the rest of the systems of the Boeing 787. So that was enough for the flight controls. You see the also thrust levers here. As I tell you, can deflect all the thrust levers of the aircraft. Also climb, descent. We have here, as I told you, tiller horizontal trim stabilizer. Over here we can trim the horizontal tail of the aircraft like this. You can pitch trim the tail down, you can pitch trim other way. So you use this way, you pitch the nose down, this way the nose down, this way is the nose up. So it makes like this the effect. You have the head-up display over here, the clutter. You can see elevator trim left, better view. Elevator trim, left click down, right click. So you move like this. You can trim up and down the aircraft. Autopilot here. Disconnect. So you can see if we do that with the trim, we can move either one over here. The horizontal tail in flight for climb descent of the aircraft. So we have also here the horizontal tail over here. Have the alternate trim. You can trim alternate the nose up, nose down like this. So you can see nose up this way, nose down this way, so you can balance the aircraft in flight and relieve the air pressures from the yoke over here using the trim of the horizontal tail function. So you're gonna see the whole left and right elevator moving up and down in flight a few degrees. You have also the autopilot flight director system panel. We have a fly-by-wire aircraft, so it has an auto trim function. If we have a failure over here of the L2, R2 or either one hydraulic system, you can see the hydraulics. We have to come down here and open this guarded switch over here, red guarded switch, from normal to cut off the red guarded switch. So it's gonna give us you can see from normal to cut off like this. It's gonna disconnect the auto trim function from the autopilot flight director system panel, so we're gonna have only the manual trim like this. Here and here the alternate pitch trim from this panel, so you can keep pitch trimming the aircraft like this. I'm gonna show you a few more things. Pitch trim down and up, and you have the elevator pitch stream up and down in flight. So we have also a few more things to note here. We have also the parking brakes here, you can see. We have the fuel flow to the left and right engine, the thrust levers that I showed you before. You can see the indications of the thrust levers over here in the display, like the N1. You can see I will talk to you about the indications of the thrust levers of the engine. So you move the thrust levers forward or aft, you will see the engine's indications increase or decrease. In the ACAS you can see the N1 is having a requested now. It takes like 1, 2, 3, 4, 5 seconds to increase to the maximum. So you see the warning will not configure for takeoff, so you need to anticipate that when flying. Takes like a couple of seconds, maybe more, for the engines to increase or decrease their power. So we have, as I told you here, the flaps. You can see we can retract the flaps over here, as you can see, all the way up or all the way down. You can see how many degrees we extend or retract the flaps: 35, 30, 20, over here 15, over here 10, 5, 1, 0. We have the speed brakes over here, extend and retract. You can see the speed brakes, extend and retract like this. So you see the speed brakes. This is the action over here. So we have a few more things to see. We have the mouse pad here. So I will show you the autopilot flight director system panel in the engine's indications now. The FS panel, some systems display over here. From the navigation display, weather radar, traffic, terrain, barometric altitude, barometric pressure actually, meaning it's radio. So the airspeed you see here and the altitude are functions of the pitot static and pitot dynamic pitot tubes. We have the air data computer over here. You can see heading reference, IRS, inertial reference system for alignment. So this is GPS receivers, pitot static, pitot dynamic, airspeed altitude difference, laser gyroscopes, and alignment of the aircraft, and also attitude over here, display, progression, deceleration, magnetic north pole, geographic north pole. All these are in the air data computer over here, this section. We have also the primary flight control computer, other thing we need to see later. So we have the fly-by-wire system. So the air data you see in the navigation, radio altitude, airspeed, altitude, increase, decrease, angle of attack in flight, pitch attitude, bank angles also. You can see from the air data computer, GPS receivers also, position, so you can see the angles that we take as we fly. So we have a few more things. The engines indications, the thrust levers. You can see in the engines we have a few more things. We have the standby instrument display, the flaps position, rudder, horizontal elevator, stabilizer trim, rudder trim, position, landing gear over here, extend and retract this handle, alternate gear over here, alternate lock override, parking, auto brakes over here. You can see auto brake, RTO, or auto brake. You can set either one, auto brake 0, auto brake 1, auto brake 2. Auto brake reject takeoff. So we have the gross weight of the aircraft, 357,300 pounds, total fuel on board 34,500, fuel temperature right now 33 degrees, so I think it's quite high. Should be less than that right now. So some errors like this. So we need to decrease the temperature over here. Should be well less than that. So now we're gonna have the correct temperature like this. For this flight, it's gonna be +1 degree actually Celsius. So we're gonna be having a few more things to see. I show you the indications. We have the engines indication. We have the engines, the next engines installed on Boeing 787-900Z aircraft. One the left wing, one the right wing. First center thrust and redundancy. Each one contains a gearbox of the FAREX. The FAREX are the full authority. These electronic control computers, one per engine, one installed per engine. Gearbox, dual channel redundancy. One channel phase, the other takes over. Controls most certain displays on the engine data you see the upper and lower ACAS. Like the N1, which is the low speed starter sub, low pressure compressor, and turbine with the turbofan with the engine, the exhaust gas temperature per engine. When the N2, which is the high speed starter sub, the high pressure compressor and turbine with the turbofan with its engine, the fuel flow per inch per hour, 1000 kilograms, 1000 pounds, solid pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. The FAREX also control the outflow valves from the 5th and 9th stage compressors of the engines. The pressurizer from the engine 5th and 9th stage, and also the bypasser compressor from the bypass stage. So we have pressurizer from the engines is applied for hydraulic fluid tanks pressurization. So we need all the flight controls you see here. Need hydraulic fluid to move around. So we have the electric control movement because we have a fly-by-wire. When we move the flight controls, the yoke around, they're electrically controlled but hydraulically actuated. So you see the elevator here, the tail needs hydraulics power and pressurizer from the engines to pressurize the hydraulic fluid, and compressors, the hydraulic pumps, the engine driving and the electric driving. You see here the thrust reversers for the engine, landing gear, extender, retract, auto brakes, parking brakes, rudder over here, flaps and slots, speed brakes, nose wheel steering over here, the tiller. We need hydraulic fluid over here, pressure, demand over here, and primary, electric driving. All are pressurized. All tanks are pressurized hydraulic tanks. We serve from the engines. Also, we have the pressurizer over here, the cabin pressurization. I will turn from auto to manual. You will see the outflow valves position. We have also the bleeder here, this section, and the pack. So you can see now we have cabin altitude 1,400 feet, rate of climb and descent. When we reach 40,000 feet of altitude in flight, the cabin altitude is gonna be like 8,000 feet, so it's gonna be differential pressure. We're gonna have 7.88 psi, rate of climb, descent, landing altitude, forward and aft outflow valves. So you can see forward and aft. Now we have the warning with yellow, cabin altitude, auto outflow valve aft and forward. We need to turn back this on. So we have all the indications of the engines here. I will explain it now. So the FAREX also control, as I told you, bleeder for hydraulic fluid pressurization, wing and engine anti-ice, air conditioning, ventilation, cabin pressurization, oxygen regulation in the cockpit and the cabin, ventilation and air conditioning, ventilation. So we need an engine anti-ice also, and so we need pressurizer for these things. We need either from the engines left to right, or from the APU as a backup. We're gonna turn on the APU in a couple of minutes to shut down the engines and restart them. It's gonna provide us with electric power. Pressurizer, it's a smaller turbine in the tail of the aircraft, in the tail cone, so you'll see how we're gonna use it. So the Farex also control the fuel metering unit, fuel flow to the engine, engine start, engine shutdown, engine failures. Also, the Farex control the fuel heat exchange sensors. We have the recirculation of the fuel in flight from the wing tanks and the center tank to the left and right engine components. Deduct heat from the engine components, cool down the engine, and heat up the fuel in flight. Because in the altitudes we find we're gonna be having the fuel freeze in flight. Also, we do the same for the lubricant and for oil. So you can see the circulation system is also automatic from the Farex, controlled from the Farex and the sensors, heat, oil sensors. Also, we have, as we climb the aircraft from the sea level all the way up, like 20, 30, 40,000 feet above the sea level, like 9,000, 10,000, 11,000, 12,000 meters above the sea level. As we climb higher, the air pressure, the oxygen level and the intensity of the air become less than half than that of the sea level. Also, the aircraft will be flying with an airspeed rate like 2 or 3 times faster than that of the sea level. So we're going to be having a higher intake of air from the front fans for compression and combustion, and fuel air mixture into the engines from the front fans. So we have a different fuel air mixture request every second, which is adjusted also automatically using the Farex. Also vice versa, as we descend the aircraft from the cruise altitude back to the airport elevation on the sea level, we're going to have different fuel air mixture are adjusted automatically from the Farex. Also, the Farex control the outflow air pressure from the engine, so we have an overpressure and under pressure inside the engines. They can control also that by opening and closing the outflow valves to lower high position. So I'm gonna show you now. We have a couple more minutes. I will show you just the basics. Autopilot flight director system panel here. You can see. So we have here autopilot engage and disengage switch, auto throttle left and right. You can see flight director here. So auto throttle left and right off. The airspeed, if we set LNAV and VNAV, we can disarm by moving the flight director off. We cannot rearm the autopilot or its modes with the flight director off. We need at least flight director on. We have flight level change, LNAV and VNAV from the flight management computer. Flight level change, auto throttle climb continues. The airspeed is gonna set for takeoff. Indicated airspeed nautical miles per hour or Mach. Autopilot disengage. Heading bank angle. Automatic and heading magnetic north pole. Heading of the airport, we're gonna use the runway 136 degrees. 136 like this. Altitude, so we're gonna set altitude over here, thousands or hundreds like this. So we have hundreds like this. We have also, so this is the modes of the autopilot. We have the vertical rate of climb descent, zeros, you can see zeros, flight path angle, also descent over here, how fast you want to descend or how fast you want to glide the aircraft, how many thousand feet per minute or steepness per metric angles increase. We have word localizer, approach for auto land, system display FS panel. So this now will display over here in the primary flight display. You will see the indications are the same with the autopilot selected and the head-up display also. So we have here, we need to start the APU in a couple of seconds. So we start the APU like this, APU on. We have electrical battery, left and right engine IDG, the gray drive generator, 120, 200 volts, 400 Hz frequency. We have the controllers. We have the primary flight control computers at all the position. So I'm showing now the overhead panel for takeoff, air data computer, flight control surfaces, FD, towing power, FD door, passenger oxygen, window heat over here, rammer turbine, and left and right hydraulic pumps. If we turn off, you will see what happens, the display. So we need to turn back on. Hydraulic pumps, primary demand, electric already at their position. We have the wing and engine ADIs here on or auto like this. so you can see the position, you can change. Also we have the lighting system and the windshield wipers. So we have here also the recorders, the cargo and APU fire, uh, engine, electronic engine control, normal and alternate mode, and the auto start. We can dump some fuel, we select the nozzles and this switch and how much remain. We have the fuel booster pumps, left and right wing, fuel tank, center tank, and the crossfeed valve balance. We can use either left and right. If we turn the crossfeed on, we can feed either engine with either pump or either tank, or balance the fuel. So we have here the pressurizer, the PAX control, and the pressurization system. Manual, we use the outflow valves for climate descent, and use the auto. We need to do nothing, it's all automatic. We have two controllers, normal and alternate. So we're gonna see now in a couple of seconds the engine start. Only need so we have also fuel control, left and right engine, fire extinguishers, transponder, rudder trim, radio management panel. So you will see the last thing before making the engine start demonstration. The systems here very quickly. So we have everything is in the overhead panel. We have the digital format here. So you can see we have hydraulic, APU, oxygen, liquid cooling, electric, left and right IDG, APU is running, the battery voltage 31 volts, and the average 180 to 100 volts, 100 Hz frequency, where the hydraulic fluid goes, left and right engine driven, hydraulic pumps, C1 and C2 electric, 5100 psi, shut-off valves also, fuel left and right, wing tank, center tank, how much fuel you have. You can see the minimum fuel temperature here, below which minus 37 degrees the fuel will freeze, so we recirculate from the fuel tanks automatically. You can see 11,000, 11,000, 11,000, 73,900, low and high pressure fuel valves, left and right engine, open feed from the left and right wing or the center. Crossfeed valve is off, but we turn on. You can feed either engine with either pump or either tank and balance the fuel between left and right. DPU is fed from the left wing using the DC motor. We have the air packs left and right, pressurizer from the engines and the APU, oxygen. We have the doors are closed, the cabin temperature, drive, land gear, temperature of the brakes, and pressure of the tires, nozzle, also ailerons, spoilers, horizontal tail. So you can see we can control here the flight controls of the aircraft. You can see the display, everything is moving normally over here. The tail, the horizontal, and the rudder trim. FS display, maintenance system, circuit breakers, also digital display. So we have the checklist, last thing to do before takeoff. So you can see all the modes of the checklist before takeoff, after takeoff, cruise descent, approach landing. So we're gonna make an engine start demonstration now. I'm gonna turn off both engines, controls to the off position. So we turn off both engine controllers like this. You will see left and right engine, fuel flow to the off position. So we need to restart the engines now. So we come over here and turn both left and right engine to the auto, controllers to the auto. So you see the amber indications are reconfiguring themselves. We have high pressure from the APU right now into the engine compressors, as you can see. Starter. So we need only to start. We have pressurizer. So we need only to start over here the fuel control like this. Both fuel control, left and right. And we can go for takeoff in 1 minute. So we have pressurized, the auto start is starting up. Pressurizer, %, 45. You're gonna see the amber indications going off like this. We have the hydraulic power back on. and we have the auto start and the engines running like this, 63%, so we can use flaps for takeoff now and taxi into the runway like this. So advance the thrust levers, parking brakes off. So we advance for takeoff right now. You can see the runway is open for us for takeoff. So we need to align with the runway over here. Use the tiller for alignment. So we advance the thrust levers over here, the full takeoff ground. So we hold a little bit pressure and use the rudder pedals for alignment. So we have 90, 80 knots, 90, 100, 120 V1. So we rotate slightly, pitch up the aircraft a little bit. So that was the pitch up. We take off 9 degrees or less of pitch attitude for takeoff. So we have the climb, landing gear up, as you can see. So we keep climbing. You can see all the indications are correct. We are 1,900 feet above the ground, 2,000 feet above the ground, but 3,700, 900 above the sea, 189 knots. The airspeed, we need to pitch down the aircraft a little bit. You can see we climb with 5,000 feet per minute. The stall speed yellow and red, the flaps. Also here you can see the terrain around you with green and how far above you are from the terrain. When you fly the aircraft symbol, we are almost 3,000 feet above the terrain. So we have the engines also indication, autopilot here. So you can see everything is normal. We have a little bit more stall speed now and the head-up display. So we need also to look outside as we fly. So this is the view of the Switzerland as we're climbing up the Swiss Alps. Over here the lakes, very beautiful view, and we need to start turning for the rest of the flight. So make the turn here. You can see we have the terrain also displayed with a little bit more color, red and yellow indication. So you're gonna have also the display of the flight line on this side. So we hold like this. You can see we can fly hands off like this. Whenever we need, there is no problem. So maybe climb a little bit higher. And we have 13 more minutes left for this flight. So we are 12,000 feet. Climb with the highest rate of climb right now. It cross through some waypoints, as you can see. So this is the view of the cockpit just after takeoff, as you can see. can see the autopilot here, the display. So we retract a few flaps, increase maybe the airspeed of the aircraft as we're flying. So we have a very beautiful view here of the Switzerland, the Swiss Alps. Over here you can see the lakes. We need to make a turn here. We have the Germany, the Bayern Munich in this direction, you're gonna see later, and the France. You can see the aircraft, the Boeing 787, and we fly into nice flight. So we need to start the turn now. So we have 11 more minutes for this flight to complete. 18,000 feet. So we need to retract the flaps. We're gonna increase the airspeed like this as we're climbing, or extend them again. Maybe keep climb. So we need to follow the flight plan here. So we have 19,000, as you can see. We have the lakes in front of us, the Germany, the Bayern Munich, the Switzerland, beautiful lakes here, and the galaxy, galactic view, beautiful star sign, the lakes, and the France in this side. So we keep climbing, 30,000 feet. We have 10 more minutes left for this flight, 30,000 plus. So we need to climb a little bit higher. And 1,000. So we make the turn here for going back to the airport. We cross very close to the Germany, the lakes, the Swiss Alps. So you can see the view of the Boeing 787 as we climb. So we are at 22,000 feet. Keep climbing a little bit higher. As you can see, use a little bit right rudder for the turn. So we coordinate the turn with the right rudder. We're very close to the stall speed right now. So we reach the stall speed. We need to increase, we need to follow these waypoints now as we fly, keep flying manually. And we have 8 more minutes left for this flight. So we cruise over here. We're gonna have the vapors, the frozen vapors, in a couple of minutes. Over here, having this beautiful view. We need a few more 1,000 feet. So we have 7 more minutes left for this flight. So we're gonna start descending now, back to the airport. So we have 7 more minutes left for this flight. We'll start the descent now. So you can see how beautiful we cruise here. We had a little bit the vapors, maybe later. We didn't reach the altitude with the frozen vapors. So we keep descending now. We need to reach faster to the airport. We have 6 more minutes left. So we leave behind us the view, beautiful view over here. We descend faster. Manual flying, and we have 5 more minutes left for this flight. So 5 more minutes left. Descend a little bit faster. It's a view of the cockpit just before going for landing. So we have 4 more minutes left for this flight. We need to start follow the flight line here. As you can see, we're gonna cross through these waypoints as we are descending. Keep descending and have a few more minutes for this flight. We need to start the turn now. 8,000 feet. Left rudder over here, 7,000. So we have 3 more minutes left as we are descending over here. Need to make a shortcut, reach faster our waypoints. So we are 5,000 feet above the ground. Need to level off, increase maybe the airspeed a little bit. We are very close to the airport. As you can see, we have 2 more minutes left to align here and land. Landing gear down, flaps also. a bit trimmed down the aircraft. Also, you can see, hopefully 2 more minutes for the landing. So we're gonna be having a nicer view over here. 2 more minutes left. Adding some thrust, some airspeed. So we're gonna have also the Lszh localizer display everything, all the information we need for the approach and landing. We can see we are in the localizer. We have the glide slope active. So we are approaching for the landing, and we have 1 more minute left. Approximately for the touchdown. Looks like 60 more seconds. The aircraft needs a little bit more airspeed. So we have 40 more seconds for the touchdown over here of the aircraft. So we are about to flare. We have some side wind. We need to balance the aircraft for the side wind. Flare over here, touchdown, beautiful touchdown, as you can see. Parking brakes and thrust reverse over here. So we use the reverse thrust, idle thrust over here. Full thrust reverse, as you can see, and rudder pedal to align the aircraft. So you can see we just made a very beautiful landing. All the aircraft parts are normal.